Hello, welcome to this lecture on modeling, analysis and estimation of three-phase unbalanced power network. So, we have been talking about the state estimation in three-phase unbalanced power network, and we were talking about the expressions of the various measured quantities. And we said that actually in this case, we can have different measured quantities PIP, QIP, IIJP, PIGP as well as QIGP. So, all these quantities are nothing but, for example, PIP is nothing but the injected power at phase P corresponding to bus I. PIJP is nothing but a real power flow over the line between bus I and J in the phase P, etc., etc., etc. And basically where P is equal to A, B, C, phase A, B, phase A, phase B, phase C. So, with that we have already written down the expressions of PIP and QIP, which we have already done in the earlier lectures, and then we started with the derivation of the expressions of IIJP, and we have got these expressions of IIJP. Now, what we have is, so here you see basically these are the expressions. Now, these quantities are all complex quantities. So, now with this, now suppose we have that YIJSL. Now, let us see that YIJ, I think shunt. The notations we have used is Y shunt IJ, sorry, Y shunt IJ PL. So, it would be Y shunt IJ PL. So, Y shunt IJ PL. So, this is a complex quantity. So, it will have a magnitude. So, magnitude is Y shunt IJ PL. An angle is something called theta shunt IJ PL, right? And VJL, this is also in complex quantity, will have a corresponding magnitude VJL, angle theta JL. I have taken a bad notations. This notations it will be better. Alpha. So, alpha shunt IJPL, and all these voltage angles are denoted as theta, and then we also have this YIJPL, also have YIJPL will also be given as YIJ, that is the magnitude and angle alpha IJPL. Correct. So, this is the case. So, then therefore, I do have IIP. So, then IIJP we are talking about IIJP would be given by L ABC then Y shunt IJPL V IL, it should be VIL, yes, and YIJPL plus YIJPL, these are all complex quantity, into VIL minus VJL. So, this is the expression. Now, we will write these expressions in the polar form. So, it would be L is equal to A, B, C, YIJ SHPL is that it would be Y shunt IJPL VIL, angle would be theta IL plus alpha shunt ij pl, and then plus yijpl is yijpl, and then it would be, let us write it down, vil angle theta il plus alpha ijpl minus yijpl vjl angle theta jl plus alpha ijpl. Right. So that is the expression of yij. So iip. So this is an, so we can write it down that it is L is equal to A, B, C. So I would say that Y is H, I, J, P, L, V, I, L cosine of theta I, L plus alpha S, H, I, J, P, L plus Y, I, J, PL VIL cosine theta IL plus alpha IJ PL minus YIJ PL VJL cosine theta JL plus alpha IJ PL. So this is the real part plus a big imaginary part. So this J is imaginary part, J of L is equal to A, B, C. So what is Y shunt I, J, P, L, V, I, L sine theta I, L plus alpha shunt IJPL plus YIJPL BIL sin theta IL plus alpha IJPL minus YIJ PL VJL sin theta JL plus alpha IJPL. Right. So this is the real part and this is the imaginary part. So I now suppose if I now say that this part is the real part. Now if I say that this part is real part, this part is of course the real part. This part is of course the real part, and let's denote it that it is IIJ P real part. This R stands for real part, and these let us denote that this is the imaginary part. So this is the imaginary part. These let us denote at IIJP I. Now this I stands for imaginary. Please note this I at the subscript denotes the bus number, but I in the superscript denotes the imaginary part. So let me, I think it is better. So this I denotes bus, denotes bus number, and this I denotes imaginary part. Right. So with this notation, I can write down that Ij P is L A B C Ij P R plus J Ij P I. So this is the case. Now here also let us write down, just to be on the safe side, this denotes imaginary operator, that is J is equal to root over minus 1. Correct. So then therefore with this I can write down Iijp. So then therefore the magnitude, so therefore magnitude so that would be equal to L is equal to A, B, C, Ij P R whole square plus Ij P I whole square. To the power half, it is the root. Right. Now with this, so then therefore this is the expression of Iijp. Now because Iijpr, you see, now my unknown quantities are, for example, in the case of state estimation, VIL and theta IL, VJL and theta JL, right. So then therefore when we do this computation, I am just leaving these expressions. So it will be some expression, it would be some expression, let me write that it would be some expression which is a function of VIL, theta IL, VJL, theta JL, right. It would be some function. I mean, if I just do this square, just do this square, and if I also just do this square and then do this little algebra and then add the, I mean, similar portions, and then if I do this algebra, then I will get an expression which is a function of Iijp, VIL, theta IL, VJL, theta L. Of course, it would be L is equal to A, B, C, right? Or rather, actually this is a wrong way of expression it. So I should say that actually it would be a function, it would be a function, it would be a function. Please note this Iijp is now denoting the function Iijpm. Iijpm is denotes the magnitude function, and it would be a function of VIABC. It is a vector, and theta IABC, VJABC, theta JABC, where VIABC we have already denoted, but then it is basically denotes a vector VIA, VIB, VIC transpose, and theta IABC, is theta A, theta B, theta C transpose. Similarly, VJABC, similarly theta JABC, right? So, this is a vector, this is a vector, this is a vector, this is a vector, and this denotes the, let me write for the sake of clarity, denotes the magnitude function. Right. So, that is how it goes. So, I am leaving this derivation of this expression as a homework. So, derivation of this expression is leaving as in homework. So, this expression is essentially homework. Now, let us look at the expressions of Pijp and Qijp. Now, what I have is, what is Pijp plus j Qijp. Now, here I need to first define, now what do I understand by Pijp and Qijp. So, first let me define it. Without that definition, it will be a wrong thing to do. So, let us define Pijp and within bracket Qijp. In the same breath we are trying to define it, that is a real or reactive power flow over the line between bus I and bus J in phase P. P is of course ABC, measured at bus I. This is very important. This is very important, please note it, that measured at bus I. Without this expression we really cannot write it uniquely. I will just show you how. So, then therefore, with this expression I can say that my Pijp plus j Qijp, please note this j denotes this complex operator. So, it would be V into I star. So, it would be, because it is measured at bus I, so it would be VIP into Iijp star. Please note over a line, right. So, it is basically, so I mean this is most important. So, we are essentially measured at bus I. So, Pijp and jQijp is VIP into Iijp star. So, now if I now implement, so now if I now use this, so what I get? So, it will be VIP angle theta IP and then whole of this into L A B C, and this is because it is star. So, I should write, so I will use this expression y shunt IJPL VIL. So, y shunt IJPL VIL, because it is star. So, this angle should be minus theta L minus alpha So it is minus theta L minus alpha shunt IJPL, then minus YIJPL VIL. So YIJPL VIL, because it is star, so magnitude would be minus theta L minus alpha IJPL, and then Y, it is plus, then YIJPL minus VJL minus theta JL minus alpha IJPL. So this is the case, right? So this is the voltage in the polar form, and this is the expression of the complex conjugate of the current in the polar form. So now let us do the multiplication. So therefore PIJP plus J QIJP. Let us multiply everything. L A B C. So it is VI square VIL whole square Y SHIJPL. This theta I P and theta IL, so it would be theta IP minus theta IL minus alpha SHIJPL, right? Then I multiply this VIL whole square YIJPL theta IP minus theta IL minus alpha IJPL, right? So I multiply it, and then minus VIP VJL. I'm sorry, I have done a mistake. Let me correct that mistakes. So it would be VIP VIL. It is also would be VIP VIL. Correct. And it would be VIP VJL YIJPL, then angle theta IP So this is the case. So this is PIJP JQIJP. So then if I now just do the real and imaginary part subtraction, so then from there I can find out. So PIJP L A, B, C. Just take the real part. So, it is VIP, VIL, YSHIJPL. So, it is VIP, VIL, YSHIJ, cosine theta IP minus theta IL minus alpha shunt IJPL plus VIP, VIL, YIJPL cosine theta IP then minus VIP, VJL, YIJPL cosine theta IP minus theta JL minus alpha IJPL. Right. So, that is how it will go. Correct? That is how it will go. Everything is in bracket. So, you see L would be ABC and it is only dependent on I and J, and L would be ABC. So, then therefore, even if P is let us say B, so it will be VIB, but VIA, VIB, VIC, and then it will be theta IB, but then this theta IL would be theta IA, theta IB, theta IC. Similarly, here also theta IA, theta IB, theta IC, here also VIA, VIB, VIC, and etc. And theta J, theta JB, theta JC, VJ, VJB, VJC. So, then therefore, I can say that PIJP would be a function of, it will be a function of VIABC theta IABC VJABC theta JABC. So, this would be a function of this, right. Exact derivation I leave to you as an homework, right. So, expansion is its homework. Similarly, I can find out QIJP, right. How do I find out QIJP? This same expression, but all cosine would be replaced by sine. So, then therefore, it will also be can be written as an function of VIABC, theta IABC, VJABC, theta JABC. So, this is also left as a homework. Same thing, it is just simple algebra has to be done. I am sure you will enjoy it, it will be much fun. So, therefore, we have managed to get the expressions for PIP, QIP, IIJP and then PIJP as well as QIJP. So, with this we will now go into the structure of the Jacobian matrix, which we will do in the next lecture. Thank you.